we are going to prove the circle theorems. See, first theorem that what we are going to prove is the perpendicular from the center to the chord bisects the chord. See, this is the center O, AB is the chord. Center O, AB is the chord, and OL is the perpendicular. So got it? AB is the chord, OL is the perpendicular. So we have to prove that this OL bisects the chord. Bisects the chord means dividing in equal parts. So we have to show that this AL equals to LB. Now, see what is the given condition? The given condition is that a chord AB, the given condition is a chord AB, a chord AB is given, circle with center O, circle with center, circle with center O, fine, and it is given also OL is perpendicular to AB, and we can write here OL is perpendicular to AB. This is given. OL is perpendicular to AB. Now, what we have to prove? We have to prove that this perpendicular bisect the chord. Bisect the chord means AL equals to LB. So we'll write it here. We have to prove that AL equals to LB. We have to show that. Now, we have to make a construction. See, whenever we are going to do the construction, we'll use the dotted lines. I have joined O to A by the use of dotted lines, O to B by dotted lines. So this is our construction. So we'll write it, join OA and OB. We have joined O to A and O to B. This is our construction. Now we will write the proof for this. Proof. See, what happens if we are going to prove it? Just observe it first. Now you can see we have two triangles here. So we can use the congruency in triangles. So we can say in triangle, now we will write in triangle OLA. This triangle, which triangle? OLA. And then we can see and triangle OLB. Now observe it, which things are equal here. First of all, I can say OA equals to OB. So we can say that here OA equals to OB. Why OA equals to OB? Because we can write radii of the circle. We can write radii of the circle. And they are always equal. Next, we can say OL. See, this OL. So we can write OL equals to OL. What? This is common. We can say this is the common thing in both the triangles. After that, we're talking about the perpendicular thing. That means this is 90 degree. So we can say that here angle OLA, that is OLA, equals to angle OLB. We will write each 90 degree. Each angle 90 degree. Fine. So now we have the three conditions. So we can say that triangle OLA is congruent to triangle OLB. Now these two triangles are congruent, we are saying. By which criteria then? By the criteria of RHS. We can say by RHS rule, these two triangles are congruent. Why RHS rule? See, first is right angle. Yes, we have a 90 degree angle. Then H is for the hypotenuse. Yes, we have the hypotenuse OA. And then one side. Which side we are talking about? OL. OL is the side here. Okay. Now, so we got this. These two triangles are congruent and we have shown it by the RHS condition. Now, after writing these two triangles are congruent, so we can say that this AL equals to LB. Now we can write it here, AL equals to LB. AL equals to LB by what? By CPCT rule. We can say by CPCT rule. Okay, so now we can write hence proved. So what we have proved, if we are drawing a perpendicular, then it is bisecting the chord into equal parts, that is this AL equals to LB. Just have a look. As we have discussed the theorem, so now we'll solve a problem based on it. See, we have a question here. The question is find the length of the chord. We have to find the length of the chord. So let's say this is the chord AB. This is the chord AB. We have to find the length of the chord which is at a distance, of 5 centimeters. See, this is the center. So this one is given as 5 centimeter. This distance is given as 5 centimeter from the center, and radius is given as the 13 centimeter. So we can mark the radius here, that is 13 centimeter. This is the radius given. So now we can write the solution. So let AB be the chord. Let AB be the chord. Circle. And center is given as O. Okay. And we have drawn a perpendicular. This is the perpendicular. Let's say this is the point L. We have the perpendicular drawn. This is the OL. So we can write radius equals to, the radius is given as 13 centimeter. So we can write 13 centimeter. Then the length of the OL, that is given as 5 centimeter. So this one is fine. Now we have done O to A, is joined O to A. Now we will write, we can observe it here, this is a right angle triangle. Why it is a right angle triangle? Because in the question says OL is perpendicular. This distance is taken as perpendicular. So now we can say that in triangle, and what is, this is a 90 degrees, so we can say that in a right angle triangle. So we will write in a right angled triangle. In a right angle triangle. See, in a right angle triangle, so we can apply the Pythagoras theorem. So we will write it in a right angle triangle. We can write OA square equals to OL square plus, that we can write AL square. And we should mention it here, what we have applied here. We have applied the Pythagoras theorem, so we should write it. Pythagoras theorem we applied. Now, this is the Pythagoras theorem we have applied here. So the value of OA is given. The value of OA is given as 13. So this is 13 square. The value of OL is given as 5. So we will write 5 square, and plus this will be AL square. So we can say this one, we wrote it here. Now what we can say, this is 13 square is how much? 169. And this 5 square is how much? 25. Plus AL square. Now this we can transfer it here. So that means 169 minus 25 equals to AL square. So 169 minus 25. So we can write it here now. 169 minus 25 will give you 144 equals to AL square. Okay. Now if we have to get the value of L, since it's a length, so we'll take the positive value. So we'll take only the positive square root of this. So that it will give us 12. We got the length of AL. Now see, what we have, we know that, as we know per the theorem, what we have learned right now, the perpendicular bisects the chord. The perpendicular bisects the chord. It means the length of the AL equals to the length of LB. As we know, we can write it as perpendicular bisect chord. Bisect chord. So therefore we can say now, therefore AB will be twice of AL. AB will be twice of AL. So 2 will be as it is. The value of AL is 12. So this is going to be 24 centimeter. This is our answer. We got the length of the chord AB. Understand everything? So just once again we can see the radius was given as 13 centimeter, the perpendicular was given as 5 centimeter. So we applied the Pythagoras theorem in a right angle triangle. We just simplified it, we got the value of AL and we have taken AL as positive because it's a distance. So it is 12 centimeter, and as per the theorem we know that the perpendicular bisects the chord. The perpendicular bisects the chord. So we can say that the length of the AB will be twice of AL. And AL value we already know, that is 12 centimeter. So we can say it is going to be 24 centimeter. You can have a look. Now we'll move to the next theorem. See what the theorem is. Angles in the same segment of a circle are equal. Angles in the same segment. So first of all, we should understand what is the segment. Let's say if I draw a line, this is the point P and this is the point Q. Okay, we can say PQ is an arc. Now if I draw a line segment, let's say PQ. So now this PQ is dividing the whole circle into two segments. So what happens whenever you are drawing a chord, that chord divide the circle into two parts. Two parts, like see, the upper part of the PQ is called the major segment and the lower part of the PQ is called the minor segment. Now what the theorem says, angle in the same segment. So you can say that let this be PR and let this be S. So we can say that angle PRQ, this is one of the angle, and next angle is PSQ. Both the angles are going to be equal as per the theorem. Because they both are in the same segment, so they are going to be equal. Now what we have to do, we have to prove it. Now see. The given condition. What is the given condition here? We can write it a circle with center O. A circle with center O we can write. Now see, a circle with center O. And we have two angles and angle, which are the angles? PRQ and angle PRQ, comma, next angle is PSQ, angle PSQ. Now these two are the angles. What we have to prove? We have to prove that angles in the same segment are equal. So we are going to prove it, angle PRQ equals to angle PSQ. This we have to prove. Now we are going to do a construction. See what, as I told you, whenever we are going to do a construction, so we do by the dotted lines. See, I joined O to P, this is my construction, joined by the dotted lines, and then we have O to Q, we have done it by the dotted lines. So we can say the construction is that join OP, this is O to P, and OQ. We have joined this. Okay, after joining it. So now we will do the proof thing. See. As we are going to prove it, so we should know one thing. The one theorem we have learnt already. The theorem is that angle at the center. See, this angle I am talking about, angle POQ. Angle at the center is twice of the angle at the circumference. So we'll write this theorem first. We will write it as we know that what angle at the center is twice of angle at circumference. angle at the circumference. Okay, we know that angle at the center is twice the angle at the circumference. Fine. So that basically means you can say angle, which angle? See, angle POQ, that is angle at the center. So angle POQ is means equals to, you can write, and twice of which angle? PRQ, angle PRQ, angle PRQ we can write, PRQ. Next, similarly we can say that angle POQ equals to what? Twice of angle PSQ. So that is going to be twice of angle PSQ. Fine. So we have two equations. First equation and this is the second equation. From these two equations we can say, from equation 1 and 2, from equation 1 and 2, you can see that the LHS of both of them are equal. So the RHS will also be equal. So we can say that. So that is twice of angle PRQ equals to twice of angle PSQ. Now this 2 and this 2 can be cancelled out because they are on the both sides. Now, therefore what we got? We got angle PRQ, this angle, angle PRQ equals to angle PSQ, this. We got that these two angles are equal and we can write it, hence proved. We did it. Okay, what we did? Angles in the same segment are always equal, but they should be in the same segment, and we discussed what is the segment. We can see that if we draw chord PQ, the upper segment and the lower segment, so these two angles are in the same upper segment, so they are going to be equal. Now we'll do a problem based on this theorem. Okay, now as we have done, the angles in the same segment are equal. So now we are going to solve a problem based on this. See, the question is, in the given figure, O is the center of the circle. This is the center of the circle, and AB is a chord. We can say that AB is a chord, and we have to find the value of this angle ADB. This angle we are going to find. So what we can observe here, as AB is the chord of the circle, so this chord is going to divide the circle into two parts. The upper part is called the upper segment and this is the lower segment. Okay, so now as per the concept we can say that these two angles will be equal. Which two angles? This angle D and this angle C will be equal. Why they are going to be equal? Because of the concept that angles in the same segment are equal. So now if I get the value of C here, so I can tell that the value of D also will be the same. Why it is same? Because angles in the same segment. Now this angle C we will try to calculate, but the question is that why we are trying to find the angle C, why we are not going directly to the angle D? See, because we know the angles here. We have this 25 degree, this is 110 degree. So these angles will help us to find the value of C easily we can do. Okay, so now what we will do here, so this is a triangle given. We can say in triangle ABC, just observe it. See, we can write the solution. The solution for this, first of all observe this APC is a straight line. APC is a straight line. So we know the concept, on a straight line the sum of angles is 180 degree. So we can say since APC is a straight line, is a straight line, so we can say this angle plus this angle. So what is the name of the angles? We can write angle APB, angle APB plus this angle BPC plus angle BPC equals to 180 degree. Why it is a 180 degree? Because we can say this is the linear pair. Linear pair as the angles on a straight line. Now The value of APB is given already, that is 110. So we can substitute the value here. We can substitute the value as 110 degree plus the angle of BPC. BPC is not given, so keep it as it is. The angle BPC will be as it is, and this is 180 degree. So we can find the value of angle BPC. So this is going to be 180 degree minus 110 degree. So that is going to be 70 degree. So we got angle BPC as 70 degree. Understand? So now this is the value we got at 70. One more thing to be observed now, this angle is given already 25. So we can go to this triangle BPC. Now just observe the triangle BPC. So we can write in triangle BPC. Now see what we have. This angle BPC is given, and we know that the sum of all the angles in a triangle is 180 degree. Okay, so what we will write, angle BPC plus this angle we wrote angle BPC, then we can write angle PCB, okay, PCB, and then we can write PBC, angle PBC, and that will be 180 degree. Why 180 degree? We can write, since all angles in a triangle is 180 degree, or we can write sum of all angles of a triangle is 180 degree. Now we can substitute the values. Angle BPC is 70 degree, so put it here 70 degree, plus this angle PCB is not known, so just leave it as it is, PCB, plus angle PBC, this is given as 25 degree, so just substitute the value 25 degree, so this will be 180 degree. Okay, so this is the way we can say this angle is going to be 70, 25. 70 plus 25 is simple, so that is 95 degree. We can say this is 95 degree if we add them, and this we can say PCB equals to 180. Now we can transfer this to that side. We can transfer 95 to that side. So that will be angle PCB equals to 180 degree minus 95 degree. So that will give us 85 degree. Now this angle C and angle D are in the same segment. So we can say if I got the angle C as 85 degree, so the angle D will be, we'll write it angle C equals to angle D, and that is also 85 degree, and this is our answer. Okay, why? Because the angles in the same segment are equal. So if I got the value for the angle C, it will be the same for the angle D, and we got it as 85 degree. Just have a look.